All right, so part 2 here. Sorry about that. But it's going to be a pretty quick video because basically it's just example number 6, and we're not going to do all of the work on this because if you remember back to test 4 lesson 2, there's a part in here where we're just going to skip and remember like the magic happens or whatever we want to say there. And that's where we have done that work from. Okay, so aside from evaluating indefinite integrals, trig substitution also allows us to find the arc length of a graph. Okay, and if you remember back, our arc length is lowercase s, the interval from a to b of 1 plus the derivative of f of x squared dx. All right, so our prep work is going to be, first of all, to figure out our, we know that f prime of x, if we were given this function right here, 1/2 x squared, then f prime of x is simply going to be x. Okay, so there's that. And then also, we need to figure out what we're in the form of. So if I was to rewrite this, all right, an interval from 0 to 1. And if we do this, it's going to be 1 plus, and then that's just x squared dx. Okay, and now we do need to make a note here that right now our interval on our interval is in x's and they need to be in thetas. And so we'll go do that in 1 second. Okay, but let's just go over here and go ahead and do our a squared. Okay, so this is 1 plus, or a squared plus x squared. So our a squared is 1. Therefore, our a is 1. And then in that situation, using your chart or your flipbook, we know that x is going to be tangent of theta. Therefore, dx is going to be secant squared theta d theta. All right, remember, we can do all of the calculations on that, or we can just know that when our x is tangent theta, it's going to jump our answer here to secant. Okay? Again, flip book right here. If we're using x equals a tangent theta, it's going to simplify it down to a secant theta whenever we're done with that. But let's look right here and let's just make a note that our x's need to be in theta measurements. Okay, so we do have theta over here as x equals tangent theta. So if our x is 1, 1 would equal tangent theta. So where is our tangent going to be? Positive 1. And we're looking from negative pi on 2, well, pi on 2 and negative pi on 2, so between there. Okay, so that's going to be, it's going to happen at pi on 4. And then where is our tangent going to be? 0 is only going to happen at 0. So now instead of it being from 0 to 1, our integral is going to be from 0 to pi on 4. All right, and then our 1 plus x squared simplifies to secant theta. We talked about that from the flip book. And then our dx is secant squared theta d theta. All right, so this is what I'm saying. Let the magic happen. Do your work. Okay, so I'm just going to put a little note here to insert our work from T4L2. Okay, so that's where we turned all those trig identities, took the integral of all of those trig identities, and so forth. Okay, and then once you do that, we're going to get down to here. And from 0 to pi on 4. Okay, so again, if you took the antiderivative of this through all the work that we did in test 4 lesson 2, it's going to take you to here. Okay, and now we are going to do our substitution. So using our pi on 4 and our 0, so the secant of pi on 4, the tangent of pi on 4, plus the secant of pi on 4, tangent of pi on 4, so forth, okay? It's going to take us, again, that's using your unit circle, so it's going to be the square root of 2 times 1 plus the ln of the square root of 2 plus 1 minus 0 plus the ln of 1 plus 0. Okay, so that gives me the square root of 2, and then this just stays the square root of 2 plus 1. And then this is 0, and then the ln of 1 is going to be 0, so that just turns into minus 0. So we end up with the square root of 2 plus the ln of the absolute value of the square root of 2 plus 1 all over 2. And calculator active. Now, obviously, calculator active, we could have put this in way up here, but that's going to give you an approximation of 1.148. All right, so your homework on this is from the book. So I will insert a screenshot of that, and that's what you need to start working on the rest of class. I'm also going to go ahead and leave for you, again, in case I use this video in the future, this is for March the 10th of 2025. So since I won't be there, I am going to go ahead and leave for you a few warm-ups that I need y'all to work on so that we can get caught up on some of those as well. Okay, so I will leave that for you, bookwork to work on after this, and then that bookwork will be a screenshot though that's also in Canvas. If you need to use your phones to look at that, that's fine as well. And then some warm-ups for you to work on as well. All right, I will see y'all tomorrow.